Connectivity. You know, you can be connected from pretty much anywhere in the world today, no matter where you are. And I know, internet does drop, wireless signals are still spotty in some parts of the world, but you know it's getting better. You compare your experience to where it was a year ago, you can see that no matter where you go, your information, your data can follow you. You don't have to be tied to your office, to your desktop anymore. You can be connected to this cloud, this power, this ability to compute answers, no matter where you may be in the world. Now the thing that has changed, and this thing fascinates me, actually, and it's going to sound a little bit orthogonal to the computing power vector. But it is the fact that the way people make things is changing considerably too. And what I mean by that is, one way to understand that is just through the idea of what is called 3D printing. 3D printing is still in its early days, but it's changing the way people make things now dramatically. Okay? Everywhere I go in the world, I hear more and more cases of people who are making products very differently. Certainly, I know people who make prosthetics for people whose legs get amputated using 3D printing because they're able to shape the leg, the hand, the arm in a very personal way and make those things. But it's not just that people can do. 3D printing today can handle 70 material types. Okay? Everything from plastic that you see over there. And if you think that people only do 3D printing of small things, this is a structure built in the desert in California, which is entirely assembled from giant 3D printing subcomponents. The fact that manufacturing, so if you think about this macroeconomically, you all now, each one of you or each of your companies has access to manufacturing capacity that it never did before. And it's almost a reversal of the Industrial Revolution. The Industrial Revolution, when it took place in the 15th century, created these factories. And before the Industrial Revolution, you had people who were craftsmen, and they made plates or forks or knives or vases or any of those things basically in their home. It was the era of the craftsman. The Industrial Revolution came, and then you had to have these giant factories and huge amounts of capital, and business became very capital intensive, very, means of manufacturing was scarce. Now, with things like 3D printing, the whole process is reversing, and people can go back to the era where you can become personal manufacturers at your own scale. But if you think this is just about craftsmen, that's not true. Because people are applying 3D printing to buildings. This is a prototype of a 3D printer that pours concrete, being pioneered at the University of Strathclyde in England. And so you can imagine that they're now applying these techniques to problems and will start to revolutionize the way buildings can be prefabricated or assembled over time and really start to dramatically alter, the way we shape the world around us. So we have big challenges, but there's technology in the form of computing and manufacturing power that's available to you. You all are in the room because 30 years ago, we democratized design software. We tried to bring that to you. What we are on the threshold of, or actually already doing, is the next level of democratization, where the power of cloud computing combined with the power of personal manufacturing will enable even more ways in which technology can make a difference to your lives. And in fact, given the fact that connectivity is anywhere and everywhere, you can collaborate with your colleagues in real time so that they can see the changes you are making in real time, and you're able, no matter where you are, be able to work with your colleague and start to make and shape designs very early on in the process in a collaborative way. You can certainly do design not just viewing on these mobile devices. You will be able to do actual editing. Again, this is already possible today, and it's not just 2D line work like dimensioning or lines or circles or arcs that you're able to do. You can do actual 3D design on tablets. So you will be able to model everywhere. And so the example I just showed you seemed like a simple piece of geometry, but how about something that is more complex? This is the front fascia of a car, which involves very high level of surface modeling. This is running in a browser on a computer. And so the person had to install no software. And the thing that has been generated, yeah, you can see all these nice push-pull operations, and it looks like magic, whatever. What you should really see here is that it's possible today with web browsers and tablet technologies to do very complex modeling. Today these devices we look at are increasingly becoming capable of doing these zebra stripes that you see come up are actually a way by which you can see that the surface that was generated is very continuous. It's called G0 continuity for all of you mathematicians in the room. You are able to do very high levels of complexity. But the real idea that all of this computing power brings is the ability to go beyond form. For the last 25, 30 years, what we've been providing and what you've been doing with technologies is trying to describe what things look like. But what computing power enables you to do today and what products enable you to do today is go beyond form to function. Which means you can predict the way something will behave, not just the way something might look or the way something should be built, but the way it will actually work. Certainly in the case of mechanical design, you can see structures and simulate what they will do before they're built. So performance. So you can look at fluid dynamics, and here is an example of something that, just like grammar checking, where you turn on in Microsoft Word and say, hey, check my spelling, your engineers will be able, or are able today, to check their work pretty much as they're designing and get performance information. This example was, sort of wind flow over the front of a car. But that same idea of fluid dynamics can be applied to consumer products, where you can look at heat being removed from an enclosure, which is almost always the biggest challenge you have when you're in consumer electronics. So the black lines is the way air will move inside to take heat away from those red hot areas. Now, if you think that all the stuff that I'm talking about is about cloud and computing and futures, there's an element of that that is true. As I said, I do think that we are in the middle of this revolution of getting information and computing power into your hands, no matter where you are, no matter what you're doing, be able to access information. Same concept in manufacturing, which is the idea of digital prototyping, where the model certainly is one way to look at the information, but it's really all the information around materials, cost, quantities, all of that is very much a part of the entire model, the entire information model, not just the geometry or the fact that you're using solids and surfaces to make, describe the way things look. So we are here as software providers to help you take advantage of those opportunities and tackle those big challenges. What we try to do, of course, is build software, give it to you through our partners, and enable you to use that technology, whether it be in the form of suites or in the form of what we are calling a cloud-based offering, Autodesk 360, what we're here to do is enable you to solve those big challenges. We see our role as people that democratize technology and help you imagine, design, and create a better world. Every day, my team is inspired by the work you all do. You know, those examples that went by early on, and it went by very quickly, of some projects that are happening here in the Nordics, whether that be a hospital, whether that be a road, whether that be a building, a new product that is being made for the global market, those are things that we are inspired by. So I want to thank you for the work you do for the planet, and I'm certainly looking forward to everything that we can learn from you and help shape the products that we are here to build and help you imagine, design, and create a better world. Thank you very much. I hope you have a great day. I'll turn things back over to you.